Hello, in this video, I'm going to present deep reinforcement learning for CO2 optimized traffic signal control, also known as Ecolight. The team includes SFU people, Pedram, Agant, and Mochen, with collaboration to Breeze Traffic, Alexei, and Alexander. So what is the motivation behind this approach? $124 billion per year is used for traffic congestion. People in the US big cities spend more than 100 hours a year in traffic. 1% cost of European Union GDP is used for this. 3 million deaths is reported due to traffic. 3 to 4 days per year of time is wasted in traffic in New York City, and better traffic control in China save 15% of the delay. So what is the current issue in the approaches? The first is the estates and reward, which is often heuristic. The ultimate goal is to optimize the travel time, but it is hard to do that. We also need to optimize the CO2 reduction directly. We also need to know the reward choice and what RL agents we need to choose. And we need to consider different road users and complex intersections. So what is exactly Ecolight? Ecolight is a reward shaping technique which prioritizes road users based on their CO2 emission class. The states of the system includes the most recent phase, the lane density, queue length, and the average vehicle type of incoming lanes. The action includes the next green phase. So what are the rewards? Rewards in the Ecolight includes 3 different approaches. The first is queue length, denoted as RQ, waiting time, denoted as RW, and pressure, denoted as RP. Here we can see the different notation and formula of these approaches. So now we need to talk about weight selection. The first is the constant, which optimizes a constant multiplier for each vehicle emission. The second is a normalized emission, which considers one value for all the vehicle in the lanes. And third is the adaptive weights. We need to consider the sensitivity analysis of these weights to our reward function. We did so on the parameters of HDV, LDV, and the bus. In here, we can see the comparison results for 2 consecutive figures and different approaches. In this side, we can see the waiting time using the SARSA, the different profile of the simulation result. And finally, in this side, we are going to see how it is actually look like in the simulation. We see the waiting time and also the weighted waiting time when different traffics are actually included in the system. We also are going to consider the queue of CO2 normalized weight and a queue of CO2 with non-normalized weight. We're gonna compare those approaches and see how they are going to react. And finally, we see the result of the queue length type 1, which actually provide a good performance compared to the other approaches.